Good morning, students. Welcome to the class of Maths. So today we have taken one question: when a stone is dropped into a well and sound of a splash, the sound of a splash when it will be generated when the stone hits the surface of water, right? So we need to understand when the stone is dropped into a well, the sound of a splash is heard in 3 1 by 8 seconds. Then we need to find the depth of the well, and it's given that the velocity of the sound in air is 352.8 meter per second. So let us assume the depth of well as x, and since the stone is dropped, right, its two journey, that is when it's dropped from the beginning, when the stone is released from the hand, it's definitely the initial velocity of that stone, that is u, it is equal to 0, right? So we have taken u as 0 over here, right? So there will be two journey. One journey is that when the stone dropped from our hand and hits the water level, right? Then at the same moment the sound will be generated. Then the second journey will be started, that is the journey of sound from the level of water inside the well to our ear above the well, when we are standing above the well, right? When we are hearing it, right? So in the two journey, that is when the stone is dropped, in the first part of the journey of a stone, the initial velocity is equal to 0, and let us assume that t as the time taken by the stone to reach the water level, right? So the two journeys, as I said, one part of the journey is done by a stone and the another part of the journey is done by the sound, right? So in the first part of the journey, the values of initial velocity is 0, t is the time, s, that is the displacement will be equal to x, right? Which we have assumed, that is the height or depth of the well, right? Till the water level only, okay? Not till the bottom, right? So by using the formula s equal to ut plus half at square, and here also one parameter which we have missed, that is given into the question, that is the acceleration due to gravity g, a small g, it's equal to 9.8 meter per second square, right? So we will use that value of g over here in place of a, right? So s equal to ut plus half at square. So putting up the value s as equal to s and u as equal to 0 into t, that means the u into t will be equal to 0. The first term will be into the RHS will be equal to 0, and the second term will be half at square, and in place of a, as we have already discussed, it's 9.8 meter per second square in as given into the question into t square, right? So this is the equation which is formed, right? That is x equal to 1 by 2 into 9.8. So just divide 9.8 by 2 to get 4.9. So x equal to 4.9 t square is our equation, one of the equation. So let us understand, if this is one of the equation, what will be the second equation, so that there are two variables x and t, so that we will be able to solve and find out the value of t, and just put up that value of t over here to get the value of x, right? The second part, the second variable, the value of the second variable will be identified just after the but just after considering the second equation, that is the when the sound is traveling in the return journey, right? The second part of this journey, right? Since the sound generated, which sound? The splash sound, right? So I am writing over here the s the splash sound, splash, yeah, the splash sound. So the splash sound generated just after hitting the stone to the water level and inside the well, yeah, then at the same moment the second part of the journey will be started, that means the journey of sound, right? So here, for the journey of sound, for sound, that is the return journey, what are the values? Let us assume, definitely it's reaching to our ear, then that means it's reaching from the water level to the top of the well from where we are listening it, right? So the displacement into this case is also equal to x, which we have already assumed over here, right? And the sound will travel like this. When the splash, when just a stone hits the water level, the sound is will travel like this and reaches to us. And here we are hearing it. This sound, this is the path of sound path, and here we are hearing where that is into on the top. So I am mentioning over here, HEAR, here. So here we are hearing the sound on the top. So just considering the return path, that is the journey of sound, that is the second part of the numerical. What are the parameters we are having with us now? That is the displacement s equal to x, right? And we know that velocity equal to displacement by time, right? And here the time taken by the sound to reach to our ear is equal to, definitely it's given that sound of a splash sound is heard after 3 and 1 by 8 seconds after dropping, right? So the total time of journey, that is including both this consists of both the times, that is both the journeys when the stone is reaching to the water level, and again when the splash sound is generated, then the journey of the sound till our ear. So complete duration, entire cycle of time is given as 3 1 by 2, 3 1 by 8, sorry. So 3 1 by 8 seconds is the total time. Then the time taken by the sound will be equal to 3 1 by 8 minus t. And what is this t? This t is the, which we have already considered in the first part of the numerical, t, that is the time taken by a stone to reach the water level into the well, right? So it will be equal to 3 1 by 8 minus t, right? Now let us do one thing. We know that velocity equal to displacement by time, right? So we can write s equal to u into t, right? Where u is the velocity and t is the time, right? So when we are considering the second part of the numerical, that is the journey of sound, when it's started and till the time it reaches our ear, it will be equal to, it will travel with a velocity of 352.8 meter per second, because the velocity of sound in air is given as, right? And after hitting, when the stone hits the water level, the sound will generate and it will only travel into the air, not into the water, right? So here what we consider, the velocity of sound in air, right? And we know that s equal to u into t, and in place of s the displacement is the value of x can be put up. So x equal to written as u into t, and the velocity of sound, as already we can take from the question, it's 352.8 meter per second, right? So 352.8 meter per second into time, and time is 3 1 by 8 minus t. Mind it, this is the only time taken by the sound. The sound will take only that much of time when it's generated. So the complete entire cycle of time is given as t, and from that entire cycle of time is given as 3 1 by 8 seconds, and from that if t will be deducted, then 3 1 by 8 minus t will be the time taken by the sound when it's get generated after the stone hit the water level until it reaches our ear, so that we will hear it. So s equal to u into t, putting up the value s equal to x and u as 352.8 and t as 3 1 by 8 minus t. So this will give our second equation. So I am just encircling over here into the red rectangular box, though it's not correct rectangle, but we can say it's a quadrilateral. Yeah. So we have two equations and we have two variables in the form of x and t, right? So from equation 1 and 2, what we get? We get x, value of x, that is 4.9 t square from equation number 1, and from equation number 2, the value of x is equal to 352.8, which I am writing over here, 352.8 into 25 by 8 minus t, right? Just solve this equation. Just solve this equation to get the value of t, right? We will get the value of t. Just you can cut this number by 7. It will be, again it will be cut by 7. So 2 times we will get t square equal to 72 into 25 by 8 minus t. So just open the bracket, just normal calculation. Okay, so just I have increased the speed of this calculation over here. So this is a quadratic equation which we have arrived with, that is, this is an equation in the form where the variable is t. So you can see one of the variable is removed, x is removed, and we are having a quadratic equation, t square plus 72t minus 225 equal to 0. This is a variable in this quadratic equation. The variable is t. Here you can see the first term and third term. Product of first and third term is 225, and it can be written as 75 into 3. So splitting the middle term, we can write it as t square plus 75t minus 3t minus 225 equal to 0. Taking common t from the first two terms, we are left with t plus 75, and taking the common minus 3 from the last two terms, we get t plus 75. So here you see the value of t plus 75 and t minus 3 is equal to 0, right? Since the LHS we have two products, t plus 75 and t minus 3, either of this equal to 0. So when the t plus 75 is equal to 0 and t minus 3 is equal to 0, we get the value of t as minus 75 from the first bracket, t equal to minus 75 seconds, and from the second bracket we get t equal to 3 seconds. But we know that time cannot be negative, right? So that's why we will not consider t equal to minus 75, and we will just reject this value. That is, we will not consider the value of t equal to minus 75. So we will completely reject the value of t equal to minus 75. So I am just crossing it over here, right? Yes. So t equal to minus 75 will not be considered. So we will consider the value of t equal to 3 seconds. So t equal to 3 seconds is the time taken by the stone to reach the water level. That is the first part of the journey. We are available with the value of time, that is 3 seconds, and 31 by 8 second is the total time for the entire round trip journey, right? To and fro, both part of the traveling. So both path of the traveling, as I said, the first part where the stone is traveling, and then the second part where the sound is traveling, right? So putting up the value of t equal to 3 second into the equation 1, we get the value of x as 4.9 into t square equal to 4.9 into 9, which will be coming as, just multiply it to the value of 9981, 1 carry 8, 36 plus 8, 44. So it will be coming as 44.1 seconds. Sorry, 44.1 meter. So 44.1 meter is the depth of well, right? 44.1 meter is the depth of well which we are searching for and solving for, right? So 44.1 meter is the depth of the well, right? And this is our answer, right? So just I am writing over here again, that is our answer, concluding the question, 44.1 meter. Just like and subscribe to my channel and put up into the comment box for any query. I will definitely get back to you. I will try my best to support you at this point of learning anytime. Thank you so much for watching. Keep on learning. Bye bye. Best of luck. So 44.1 meter is the depth of well which we have derived over here. So writing over here over into the at the question also near the question here we have written that find the depth of the well. So here we will write 44.1 meter, right? This is our answer. Thank you.